Hello everyone, my name is Mr. Emil Vihandre and welcome to Physical Science.
Our mouth for today is to give evidence for and describe the formation of heavier elements during the star formation and evolution. Previously, we had a different epoch of the Big Bang. Today, we're going to view the evidence on the existence of the Big Bang Theory. In our video for today, we are going to discuss the three evidences for the Big Bang Theory, mainly the hydrogen and helium, redshift, cosmic microwave background. First, and the easiest to believe, scientists have spent years in data collection, and they found that the two elements, hydrogen and helium, make up most of the universe. Hydrogen being the most abundant of the two. Scientists believe, since the Big Bang Theory starts from nothing, it was only logical to see the first and second element in the periodic table serve as the building blocks for the rest of the universe. Recording white light radiated from the sun or stars can be seen as a spectrum of colors, or the rainbow. However, because of the presence of elements such as hydrogen, we could see black lines on the spectrum. Keep note that hydrogen resides inside our sun and all kinds of stars. They found that hydrogen readings from our sun were similar to that other star, but differed in what we call the redshift. Before we go any further, recall that colors are different because of their wavelength. Observing the three colors, which has the longest wavelength? Yes, it's red. And the blue wave looks compressed than the rest because of the shorter wavelength. Light can change in color, but the wavelength must also change. To better understand redshift, let's try this example. A boy looking at a stationary star, we see that the light does not change color, and he perceives it as yellow. What if the star moved toward us? The distance between us and the light source shortens, and let's see what happens. Why did it change color? It's because the distance shortened, and so does the wavelength shorten as well, which caused the change in color since blue has a shorter wavelength. We can also think of it as the wave was compressed, so it changed to the color blue. What if the star moved away? What could be the result? Yes, the star would appear red. Light would change its color since it moved a longer distance. It looks like the wave was stretched, thus having a longer wavelength. Remember, red has the longest wavelength. We can relate this to the physics concept of the Doppler effect. Sound waves are compressed and stretched similarly. Let's see what happens to sound as we hear the ambulance coming closer. As the ambulance came closer, its wavelength shortened, making the sound more intense. But as the ambulance goes farther away, the wave travels a longer distance, stretching it and causing the wavelength to grow longer, making the sound less intense. Keep note, the longer the wavelength, the lower the frequency and energy. The cosmic microwave background. Did you have this old television? Have you ever heard and seen this type of signal? We may not know it, but this was the microwave found throughout the universe. And when I say universe, I mean it's everywhere. Scientists were able to isolate the microwave radiation, and they were able to measure the temperature at 3 Kelvin. What's even more amazing, they were able to determine that the 3 Kelvin temperature came from a much hotter and earlier time closer to the beginning of the Big Bang, the Hadron Epoch. The Hadron Epoch started the formation of elements when the universe was at 3000 Kelvin, hotter compared to the present universe of 3 Kelvin. How did the hotter universe dramatically change to a cooler 3 Kelvin? Before the Hadron Epoch, the universe was tiny and very hot. But during the Hadron Epoch, the universe greatly expanded. So that means light or microwave had to travel a longer distance, which means they have to stretch longer to reach their destination. If they stretch and reach a longer wavelength, what happens to the temperature? Like energy, it would decrease. So much that today it's only 3 Kelvin.
I hope you learned something. See you in the next video. Goodbye!